Hi, welcome to this video. In this video I'm going to demonstrate two remote control libraries for the PIC microcontroller. One is for the Philips system and one is for the NEC system. And it's all programmed with the JAL programming language. So what will be the contents of this video? First a short introduction, then a short summary of the Philips infrared remote control systems that are being used. The same for the NEC infrared remote control system. Then the functions provided by the remote control libraries. The hardware that I'm using for this demonstration, the demonstration itself, and at the end of this video you can find some references. If you look at the infrared remote control, it's a very inexpensive way to build remotely controllable hardware using a simple microcontroller. But each manufacturer of consumer electronics has its own remote control system format, but also the carrier on which the infrared system information is transmitted. In this video I'm going to show two libraries, one showing the Philips RC5 RC6 remote control system and one for the NEC infrared remote control system. So a very short summary of the Philips remote control system. You can find the rest of course on the internet. Philips has two infrared remote control systems. One is the previous called RC5 system, which was capable of addressing 32 devices and 64 commands. But since RC5 has two start bits and the number of commands was limited, they used the second start bit, now also called the field bit, to create RC5 extended. So it was capable of addressing 32 devices but now having 128 commands. The successor of RC5 is RC6, which is capable of addressing 256 devices and 256 commands. This is called RC6 mode 0. But RC6 has 8 modes, modes 0 to 7, of which mode 0 is used for controlling consumer electronic devices. The other modes were used, for example, in mode 1 was reserved for bidirectional string transmission, mode 2 for pointing devices, and mode 7 for original equipment manufacturers. Both systems use biphase modulation or Manchester encoding, where a bit has a fixed width, but there is an infrared signal followed by a pause. And this is a very reliable transmission for infrared systems because you don't need any additional error correction or error checking bits. When you press a key, the whole infrared message is transmitted. And as long as the key is pressed, the same message is repeated. So when you release a key and press it again, there's a special toggle bit which flips to indicate that the key was released. And the carrier frequency is 36 kHz. So the short summary for the NEC infrared remote control system. It is capable of addressing 256 devices using 256 commands. But also here they introduced the extended format, capable of addressing 65K devices using 256 commands. The system uses pulse distance modulation, which means there is a pulse and there is a space, and the length of the space determines if the bit was a 1 or a 0. This system is more susceptible to errors, but that is solved by NEC by adding extra bits in the message. For example, the address and the command byte are transmitted twice, where the second transmission in the same frame is inverted. But in the extended system they use the inverted address byte to extend the address range, so they are only now using the second command byte for error checking. When you press a key for the first time, the whole message is transmitted, but if you keep the key pressed, then only a very short repeat message is transmitted. And the carrier signal is 38 kHz. So what are the functions provided by these libraries? As I said, there are two different libraries, one for the Philips RC5 RC6 system and one for the NEC system. Both libraries decode the infrared message on an interrupt basis, and for the PIC you can decide to use the external interrupt or you can use any of the interrupt on change pins. Decoding is done on both edges of the received infrared signal, and this is important because this will prevent that the message is decoded incorrectly, resulting in the incorrect command or address byte being received. The library uses 60-bit timer to measure the bit time, and it assumes a timer clock of 1 MHz, but you can also use other clock frequencies. And if you change the clock frequency of timer 1, you can scale the bits accordingly. And the library accepts a variation of 25% on the bit times, and this increases the sensitivity of the remote control decoder. So the Philips library, it has a few functions. First, you initialize the library, which means that you enable the required interrupts. Then when a message is received, it will indicate if it's an RC5 message or an RC6 message. Then you can read the information, which is the address, the command and the toggle bit. The next system is almost the same. You initialize the library enabling the interrupts. Then you can set the library to support the extended NEC protocol, because the default is a standard NEC protocol. It will indicate when a message is received, or it will indicate when a repeat message is received. And it will return the received address or the extended address and the command. So the hardware that I used is based on a PIC 16F1A25 microcontroller running at 1 MHz and using its timer system clock of 1 MHz. But you can also use any other PIC. I'm using the MAX232 driver IC for the connection between the PIC and the serial interface of the PC. I'm using a T-stop infrared receiver for demodulating the infrared signal. So for the Philips system I'm using a module with a carrier frequency of 36 kHz, and for the NEC system a module that is capable of demodulating a 38 kHz signal. You can use, let's say, a 38 kHz module for a 36 kHz signal, but the sensitivity will decrease. The infrared module is connected to the external interrupt pin of the PIC, and as I mentioned before, you can also decide to use one of the interrupt on change pins. So the schematics diagram is quite straightforward. The heart is of course the PIC microcontroller. On the left you can see the connection of the infrared receiver, which is connected to the interrupt pin, and on the right the MAX232 driver IC to connect to the PC. So I will demonstrate the two libraries. There are two sample programs for this library. The one is based on an SSD 1306 display and one using the serial interface. And for this demonstration I'm using the serial interface sample program. So the following information will be shown. The type of message, RC5 or RC6, which is of course only for the Philips system. Then the infrared address, the command and the toggle bit, where the toggle bit is only for the Philips system. And I added a repeat counter. And for NEC this is the repeat, it uses the repeat messages, and for Philips is the complete message with the same address, the same command and the same toggle bit. I will also show the reliability of the decoder by using two remote controls. So I will use one remote control for sending a message and a second one to disturb the message. You will see that on the screen because the repetition will sometimes stop, but you will also see that there's not an incorrect message received. So demonstration 1 is the Philips RC5 and RC6 mode 0 system. So here you see the RC5 RC6 mode 0 remote control program. If I'm pressing a key, you see the message, the toggle bits, address command, and the repeat is just a counter which I keep track of. Each time I release the key, the toggle bit changes and the repeat counter resets. I also have an RC6 remote control, and if I use that you see that the RC6 message is received. I can also use the RC5 remote control and using also at the same time the NEC, and you will see that sometimes the repeat message the repeat stops, but you can see there's not an incorrect message decoded. If I use RC5 and RC6 at the same time, you see that I'm receiving RC5 and RC6 messages, but you will see that I'm not decoding an incorrect message. And demonstration 2 is the NEC system. Here you see the NEC format. As I mentioned before, it first starts with a command and then a repeat message. If I'm now going to use another remote control, you will see that sometimes the repeat stops, but there's not an incorrect message decoded. If you want to know more about JAL and the programming language, you can visit the JAL website. You can download the JAL package, which contains libraries, sample programs and the JAL compiler. And if you want to get started, you can have a look at the video Getting Started with JAL. If you have questions on how to use JAL, there's a very good JAL tutorial that you can download from the JAL website. You can also post your question in the JAL Google group. If you find bugs in libraries or in a compiler, or you have specific requests for libraries, you can visit the JAL lib Google group. And all the sources for the JAL compiler and for JAL itself can be found on GitHub. I hope you liked this video, and thanks for watching.